Hello everyone. Today we'll be doing a new TryHackMe room that is locked down. So without further ado, let's get straight into the box. So first off, we start with the Nmap scan. So Nmap-A for aggressive scan, -VV for verbose and IP. Right off, we see two ports open, 22 for SSH and 80 HTTP. So let's see the port 80 HTTP. And right off, we see contractor.thm. So looks like we need to add it in our etc host file. So let's do it. Yeah. So sudo etc host this and oops, not the HTTP part. Yeah, perfect. Now reload the page and we successfully see it. So there we have our coronavirus contact tracer and our webplaza tells us that it's using Apache and PHP. All right. So we don't see anything useful in the source code except some links, but we don't have to do anything. So right off we see a admin panel page. So we go into this and we have username and password field. So right off when I see something like this, I usually try some random passwords like admin or admin password, but looks like they do not work here. So as of now, we can try some SQL injection. So the common payload of SQL injection that first of all comes to my mind is comma or 1 equals to 1 dash and dash the comment, and then just copy this and paste this here and sign in. And looks like we successfully logged in, and that also as admin. So we also see the version number here, the CTSQR version 1.0. So let's search this up quickly. CTSQR version 1.0. Oh, whoops. And we see something that is COVID-19 contact tracing system with QR code scanning. So let's open it in a new tab. And we see that this version suffers from a remote SQL injection vulnerability that allows for authentication bypass. So we have actually already exploited this vulnerability. So we don't think that we can do anything ahead with this article, I guess. Moving on, we have something new in here, attackerkp.com, and nothing here. Okay, so if we enumerate this a little bit, you'll see we have individual list, establishment list. So right now we are searching for a way by which we can upload files, maybe, so we can get a reverse shell right off. Uh, you can go to settings actually, and here you can see this choose file. So we can try uploading a reverse shell here right now. So I have already downloaded the reverse shell. You can download it from Pentest Monkey website. So that's we have. Let's try uploading it, and let's open Netcat listener quickly. So let me intercept this request on Burp, so just so we know what is happening. So let's intercept this on Burp, update, and we see right off the classes, system settings.php, then update settings. So it's making a post request to this URL with the name that is Corona contact tracer, system name, and the file name that we are uploading. So yeah, that's it. So I'm going to intercept the response to this request, and we see 200 OK and a 1. So if I see 0 or 1 in any response, I usually think that 0 is for false, that the update has failed, or if I see 1, then it's true that update has been successful. So let's provide this again, and turn off the intercept, I guess. So it looks like the file did upload, but we do not yet nowhere the file has been uploaded. So if I copy this image location, I go there, then we have dist image and no image available. So I'm not sure where the image has been uploaded. So let's quickly do a GoBuster scan. And GoBuster, yep. So I'm appending PHP extension, HTML and TXT. And we see uploads directory. That's interesting. So going there, and we get a forbidden, of course. So but we can try appending what we just uploaded, php.php, and it is not found. So maybe the application changing the name or it's uploading elsewhere. Then we have admin, plugins, nothing useful. Then we have classes. All right. So we kind of stuck here. We do not know where the files are being uploaded. But we saw something unusual before that could help us get a reversal. So intercept on. We're gonna catch this SQL injection request. Sign in. And let's send this to repeater. We send the request. And we get status incorrect. Not sure why. Okay, R1 equals to 1 dash dash dash. We send it and we get status success. Okay, so we are logged into the application, but can we somehow get the admin hash from here? Well, we can, but it will take a lot of time. So you can try using the SQL map tool here. You can just copy this request and paste it in a text file, and then with the SQL map dash R flag, you can specify the text file, and within 10 to 15 minutes you will get the admin hash. But that's not much useful here. That's not gonna help. So we'll look for something else. So as before, we saw the application name as CTSQR. So if we search a CTSQR on Google, we version 1.0. It's version 1.0, I guess. Yeah, so right off we see a COVID-19 contact tracing system. So now we know that the name of this application is COVID-19 contact tracing system. But are you sure that this is the only exploit available of this application? Nope. So we can try using the search exploit and we search for COVID and we get a couple of results back. The first one being a remote code execution unauthenticated. Well, that is interesting. So let's copy this. Let see where it is located. Copy this to our current location. Okay, so let's try launching it direct. This tells us the usage, so we need to specify the target IP. So I'm going to specify the conductors of the THM, then our attacker IP, that is our IP. So my IP is 10.17.1.253, and then the port 1234. So let me launch a reverse shell here, enter, and it says the file upload seems to have failed. At this point, most of the people would not see the source code of this Python file, but we will continue to debug this exploit. Let me zoom in. Yeah, so the description tells us that this application is vulnerable to RCE, and right off we see that the payload is this PHP reverse shell, and then it's going to get a reverse shell back with the help of netcat binary. Next thing we see here is that it's trying to upload a PHP reverse shell. So it's making a post request on this URL. So, okay. So you see something weird here that is making our script to fail. That is ctsqr location. And then it's going to the classes, then system settings.php. If you noticed, then we do not have any directory named ctsqr. We directly have classes here. So we need to remove this ctsqr from here. So we remove this ctsqr and let's see, remove ctsqr from here. Save it, launch this again. And this file upload seems to have been successful. Okay. Um, I forgot to read the comments. You should read the comments. It says the file we uploaded previously is expected to be an image that the web app tries to embed into the login page. Okay, so it's uploading a file as image that is embedded in the login page. So if we go to the login page, then we should see our payload right there. So should I log in.php? Oops, I have to log out first. And there we have it, system image. There was the image before here, but it has gone because it's a payload now, and PC uploads, then php. Oh, okay, it's our payload that we previously uploaded in the settings. So if we go here, it's just not found. I don't know why. Pretty odd. It's weird. Okay. So right now we don't know if our Python script is working or not. So we can debug this with the help of burp by passing our Python request to burp. So let me quickly do it. And if you don't know, then you should see it because it's really interesting and it helps you a lot to debug the Python applications. Okay, so we click on add, bind to port 8081, request should be redirected to contact tracer, and we click redirect to port 80, and okay, perfect. So let me turn on the intercept. Let me close this co-buster scan. Now if I do Python 3, this instead of contact tracer, I'll specify localhost 127.0.0.1 and port 8081. So this is what is specified in interface 127.0.0.1 8081. The request made to this host will be redirected to contact tracer.thm. If we turn on the intercept, we press enter, and we start off, we see the request made. So we see that it's going to the classes, system settings.php, and update settings. Okay, so it's on the settings page. It's updating the name to pound, and it's uploading a reverse shell file. The name of the file is this. Let me copy this, and then it's uploading it as a PHP file, but the name is img, and it's uploading a PHP reverse shell, but it's using a netcat. So let me forward this request first. Let's see. And we see 200 OK. It says 1, so true that changes have been made. And then it goes to the login.php. Let me intercept this request. And we see 200 OK. And I just pasted the file name here. And we see that the file is uploaded as this name. Okay. So if we would not have searched this file name, then I don't know what would have happened. So forward and it is done. We refresh the page. Okay. So we see the file name was this, so contact tracer.thm/uploads, slash this. And of course, we need to have our reverse shell open, sorry, netcat listener open. 1, 2, 3, 4. And we do not get anything back. And that's because, let me do it again. Intercept on. Yep. So that's because we are using a netcat to get a reverse shell back. So we are not sure if the netcat does exist on the machine. So let's do a simple PHP reverse shell, PHP system, and $_get parameter name CMD. You can name it anything. Let's intercept this. Let me first copy the file name. Yeah, forward this. We see one. Perfect. Oh, we can see the file name on the login page because it's going to the login page, and I guess the file name, yeah, we could see the file name on the login page. Let me go there, refresh the page, and this system image should be the file name. Yep, it is. Or what? Well, this should have worked. Um, that's odd. Okay, let me do it again. I don't know what's happening. Intercept on. Sorry for the sloppy cut. I have to go somewhere. So let's do it again. Python. Okay, turn on the intercept. Yeah. So this is the file name. Let's copy this file name and change our payload. Oops. Yeah. Change our payload to system $_get cmd. Yep. And intercept the request just to confirm. Yep. Uh, update did update has been successful. Intercept this request, paste the file name here, and we see the full file name here. I'm curious. I don't know why. Okay. Turn off the intercept. Let's go here to uploads, then the file name, and let's append cmd parameter as id. And we do have our code execution right here. Okay. So we are www-data. We are in the uploads directory. Okay. So let's quickly see why our netcat payload was not working. So if we do which NC, then the NC does not exist on this box. So let's try getting a reverse shell back with the help of Python. And we do have Python. Okay. So reverse shell cheat sheet. Copy the Python. Paste it here. Replace the IP. Open a netcat listener. Change the Python to Python 3. Press enter and we will get a reverse shell back. Nice. Now Python 3-C. Usual stuff that you do every time. Nothing new here. Export term equals to xterm, so we can clear the shell. Okay. Okay, great. So let's see what users we have on this box. So cat etc password, grab sh. We see root, Maxine and Cyrus. Okay. So let's see if there are any internal services running on this box. Right off, that is interesting. We see 3306. So 3306 port is registered for MySQL service. Therefore, let's get into the MySQL. But before that, we need to know the username and password. Without that, we cannot get into the MySQL shell. Okay, so let's enumerate it a little bit. Let's see. We have config.php, pet config, and we see username dev and the password MD5 hash. Well, I don't know what is it. We can try to crack this on crack station. Looks like a MD5 hash. And it says not found. So we're gonna leave it. Yeah. Let's look at the other files. We can do a recursive listing, so ls-r. Okay, well, that is too much. Okay, let's do ls-r with the help of grep. So ls-r, grep. We need a database file, so we'll say db, and we have db.js. I don't know what it is. So we have a couple of directories here: admin, build, classes. So if you go into the classes one, you'll see that db connection.php file here. So let's get it out. So get classes and db connection.php. Right off, you see the host localhost, username CTS, and the password is this. The database it's using is CTS underscore DB. Okay, so let's do MySQL dash u CTS and dash P for prompting the password. And where the password we get in, we do show databases. We have two databases here in use. The one we need is CTS DB, so we'll say use CTS underscore DB. Database changed. We say show tables. We have a couple of tables here. The one we need is user, so select all. Oops. Yeah, select all from users. We have admin and the password is this. So it looks like MD5 hash if I am right. So we can try creating the MD5 of this file. And let's see how many characters are in this file. What? WC-C. Well, that is really, really odd. Oh, okay, my fault. Sorry. Yeah. WC-C. You have 33 characters here. And this one should also have 33 characters if it's 75 hash. WC-C. And it does have 33 characters. Okay. So it's 75 hash. We can go to crack station. Enter the hash. Pass the security check. Crack hashes. And we do see a result. It says sweet pandemonium, I guess. Okay. So, okay. So, we have the sweet pandemonium password of the COVID-19 tracing system, but we do not have anything to do there because we already have a reverse shell. So we can look for password reuse and we can try logging in as one of the users using this password. So let's first try Maxin. Plus SU Maxin. Paste the password and it says authentication failure. So moving on to another user is Cyrus. So Cyrus and paste the password and we successfully get logged in. Okay, so let's get into its home directory. And right now we see something unusual that is test virus, and of course a user flag that you need pretty bad. Yeah, test virus. So let's see what it is. So it says EICAR standard antivirus test file. Let's see. Yeah, so it's a EICAR virus test file. So if I'm right, then EICAR file is generally a string that is considered to be a virus, just so that you can check whether your antivirus system is working properly or not. It's a test file that every anti-malware service should detect. So let's do sudo dash l. Oops. Yeah, so the process was this. Let me paste it somewhere so that I do not lose it. Yeah. Okay. So we can see Cyrus can execute scan.sh as root. So if we execute it, it asks of it is asking for the path. We say root, and looks like it is scanning all the files that are in the root directory. Okay, let's view the source code of this file. Scan.sh. So it's reading the path we give it. Okay, so actually it's taking the path from us and throwing it into the target variable, and it's checking whether the target does exist. And okay, so it's checking the whether the path is valid and whether the file is readable or not. So dash r is to check whether the file is readable, and dash e is to check whether the file exists. Then if these two conditions satisfies, then it goes to the user binary ClamScan binary. ClamScan is an antivirus, I guess, Linux antivirus. Yeah, so ClamScan uses Node.js to scan files on a server. Okay, yeah, it's a command line antivirus scanner. Okay, so user bin ClamScan, it scans the entire directory and it copies any found threats or viruses to the virus's quarantine folder. And then it uses chown. I don't know how to pronounce it. I guess it's CHOWN chown maybe. Okay, so it uses chown with the dash r flag that is recursive. So Cyrus home. Okay, so it's whatever the files are in the quarantine folder, the chown makes Cyrus as their file owner. Okay, so we can test it out pretty quickly. So we'll say sudo opt scan.sh. But before that, let's see the quarantine is empty or not. Quarantine. Oops. Let's actually like quarantine. Yep, it is empty. Okay, so sudo opt scan.sh. We'll say home Cyrus. And it does find EICR MD5 unofficial found test virus. You see MD5 looks like uh, it's matching the MD5 sum to detect viruses. We'll get into that later on. So let's quickly go to the quarantine folder. And yep, we were right. The owner of this file has been changed to Cyrus, and Cyrus can read the file and write the file. Okay, so what if we define what our virus is, and we say that the root file, root.txt file, or the etc shadow file, etc password file that are sensitive are viruses. So this program will copy those files to the content folder and make us the owner, and we can successfully read them. That is interesting. So we can do that with the help of YARA rules. So if you don't know what is YARA rules, then you should probably search about it a little bit. I'm not going to go in depth of it because it's a vast concept, but you should know that let's define our own YARA rules in ClamScan, I guess. And right off we see ClamAV. So what is ClamAV? I searched for ClamScan, but it's showing ClamAV. So maybe these two terms are related. So the part of Clam antivirus. So Clam, Scan, Clam, AV. I think they both are same. So if we see find slash that's name Clam AV, we are not going to output any errors. So that is why we appended to greater than dev null. And we say etc Clam AV. And user share bug, doc, wildlife. So the interesting one is this. We should go in here. We do ls-la and we see main.hdb file. If you cut this out, and you'll see EICR MD5. This is the MD5 string of EICR virus file. And that is how the antivirus is detecting it with the help of MD5 hash. You see right here, unofficial found. Okay, so it's detecting with the help of MD5, but what if we want a YARA rule that will detect the file with the help of the contents in it, or we say with the help of the strings that are in the file? Like in the etc password file, we have root, of course, always, all the time. We have root string. Uh, so if there's a string called root in any file, then it should be considered as a virus. So we can quickly create a YARA rule for that. We say YARA rules ClamAV documentation. You scroll down and you will see the format of this. It says rule, then strings, and then the condition. So let's quickly do it. Uh, I'll say I use nano and I'll say custom.yara. Okay, so that rule is going to be give me your shadow file and curly braces, and then it goes for the strings. But instead of doing this way, why not just copy the format? Perfect. Let's say give me your shadow file. Strings. I want you to detect the file that contain the text root, and I do not want any file size to be in condition. I just say ABC is the condition, like root is the only condition. This text is the only condition. We save it. Let's transfer it to our vulnerable machine. So wget does not exist on this machine. So we will use curl 10.17.1123 slash custom.yara then dash o flag for the output, and it is here. Perfect. So now our rule should work. So sudo opt scan.sh. We want the path to be etc because that is where our shadow file does exist in the etc shadow. So we'll specify the file only. We need etc shadow. And it says yara.give me your shadow file. And etc shadow copied to home Cyrus content. Perfect. cd, and we have our shadow file here. So we say get shadow, and we see the hashes of Maxine. Let's copy this. And we do not have the hash of root. Uh, okay. So hash.txt. Let's try cracking it with the help of John. We'll say John. Oops. Hash.txt word list. So included one password hash. No password hash is left to crack. So yes, I have already cracked the password. So I cannot crack it again. So I'll just say just the show hash. And we do get a password back, that is Tiana. So we do Maxine, Tiana, and we can log in. So we do sudo -l here, and we can see that this user can execute every command as root. So we'll just get the root shell with the help of sudo su, and we are root. Perfect. And you can now fetch that root.txt file. Okay, so I hope this walkthrough was pretty much educational. I tried to cover as much as I could. So thanks for watching.